Dimensional analysis, that process in chemistry where there seem to be a lot of steps and some crazy junk goes on in the middle, and then you wind up with an answer with some units. What we're going to do is kind of go through the stuff that goes on in the middle. The objective is to convert from one unit to another. Right now we're doing SI prefixes, and we're converting from a value like meters to another value of the SI prefixes like millimeters or kilometers. Here are the basic steps. Number 1, determine the starting unit. That's the given information. Number 2, determine the end unit. That's the question being asked. Number 3, determine the conversion factors required. Yep, that's it. So the problem is in determining these conversion factors that are required. This is where you have to know the SI prefixes and their values, because that's where the conversion factors come from. A conversion factor is an equivalency. It's two expressions that mean the same thing, so when set up as a fraction, they have a value of 1. They can be written in more than one way, usually. Let's look at these examples. It's the same thing to say 100 pennies is $1 as it is to say $1 is 100 pennies. There's a similar example here with 1,000 grams and kilogram. But there are still more different ways you can write it. You can always state that 1 kilogram has a value of 1/1000th of a kilogram, since it takes 1,000 grams to make a kilogram. Okay, so you heard that I bobbled. I was saying 1 gram is 1/1000th of a kilogram. I think I said kilogram twice, but you can see by what I wrote what I meant. Now in this particular method, they're having you put 1 in the bottom of the first fraction. We actually just skipped that. That's implied. But we do start with the given unknown as the first expression. Then we go to the conversion factors. Again, this is something where both expressions are equal to the same value. We don't want to change the value. We just want to restate it in different terms. A mile is still a mile. We just want to know how many feet it is, not change the mile. It's always set up so that the units cross-cancel. Mile on the top in this step would be on the bottom in the next step so that they cross-cancel. The last unit standing is the unit we'll express the answer as. Now as far as the math goes, when you set up these brackets, you multiply all of the expressions across the top. And then the ones across the bottom, you're going to do divisions for each and every expression. That's how you're telling your calculator that it's in the bottom of a fraction. In the end, you'll have your remaining unit to express your answer by. You'll simplify to the correct number of sig digs. And then because Miss Stanley's old and wears bifocals, you're going to circle or put a box around your answer to make it easier to grade. Thank you very much. Let's look through some examples to get you comfortable with this whole method. Example 1. Convert 23 miles to feet. So here is the original expression. We don't do this step, just scratch that out. Then we have our conversion factor. 5,280 feet is a mile. Now you don't have to know that. If I needed you to know that, we would have memorized it and had it on our quiz today. If you need that kind of a conversion, we'll just Google it. Now for the math, you're going to multiply everything across the top. Everything on the bottom is a 1, so we'll just ignore that because that doesn't change the value. So they got an answer of 121,440 feet, but that's not the correct number of significant digits. So we want to make sure we state it as the correct number of significant digits. We need 2 because the original data, 23, is 2 significant digits. So we need the 1 and the 2. We're going to have to move the decimal over. Looks like 5 places. So it'll be 1.2 times 10 to the 5 feet for the appropriately stated answer. All right, second example. Convert 36,000 feet to miles. Again, ignore that. We're going to start with the given information, 36,000 feet. We have a conversion factor because 1 mile is equivalent to 5,280 feet. Multiply across the top. Divide across the bottom. Don't let that time sign fool you. When we put it in our calculator, we're going to go divide. And then you get the final answer. This one's not stated to the correct number of significant digits. They've reported 1 extra digit than is necessary. 36,000 has 2 significant digits. There's no decimal, so the zeros are not significant. They have value. They're just not significant. So our final answer would be 6.8 miles. A couple more examples. Look at this one carefully where they're converting from gallons to liters. Multiply across the top, divide across the bottom. This one is stated to the correct number of sig digs. Second example, convert 1.7 kilograms to grams. Now is when we're getting into these conversion factors that we recognize. We know that 1,000 grams is a kilogram. We would have written it as 10 to the 3, but we'll give them that. If we want to do it the other way, we would say 1 gram has a value of 1/1000th of a kilogram. But when you do the math, it works out the same because 1.7 times 1,000 is the same answer as if you have 1.7 divided by 1/1000th. Okay, you're still going to get 1,700 grams for your answer. And that is appropriately stated as 2 significant digits, since there's no decimal, which is what we were given originally. So that one's done. 2 more examples. Now, with these, they're going from prefix to prefix. There's no simple way to have a conversion factor that goes from prefix to prefix without having errors. So I always say, take it to the base unit, and then convert further from the base unit to the other prefix. When you've done with the setting up of the bracket, you just multiply everything across the top, divide everything across the bottom. All the units should cross cancel like they do in this example, and the last unit would be your answer. It looks like this one has a typo. That should have been deciliters, and that one should have been deciliters. Okay. And they had to move the decimal to get it in the correct numbers format for scientific notation, 1 digit, 1 decimal, which changed the exponent from 10 to the 7 to 10 to the 8. The final example is the same thing, and they're starting with something with a prefix. They take it to the base unit of gram, then the further step of converting it to the final unit of kilograms. And again, the digits aren't coming out right because they got 8,125 times 10 to the negative 12 kilograms. But that's not proper scientific notation. Scientific notation is 1 digit, 1 dot. And that changes the value of the exponent. At this point, I actually recommend that you go back and watch this video again, because it's going to start to sink in. Let's do a quick recap of what we've discussed. Number 1 is to know those prefix values. You just can't do dimensional analysis without knowing those. That would be like trying to drive a car and you never learned how to turn it on or how to put the key in the ignition. Go into this with the expectation that your units are going to cross cancel. Conversion factors have to be the exact same value top to bottom. That's what makes them a conversion factor equal to 1. And as far as the math and your calculator go, you multiply everything across the top, you divide everything across the bottom. And at this point, everything's just details. The number of significant digits for your answer, putting a circle around it, making sure you've kept up with the units. That just comes with some practice and a little bit of diligence on your part. So, watch this video again. Get a handle on dimensional analysis because it is not going away.